Hello, 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 and welcome. It's really nice to see you. Well, actually, I can't see you, but you can see me now. Okay, so this is the 42 Tutoring Introduction to A-Level Physics. Now, I normally do masterclasses much later on to students that have done a significant quantity of A-Level Physics, but this time, it's the first time I've done an Introduction to A-Level Physics to help you as you start your A-level physics journey. So I hope you're looking forward to it. It should be good fun. It's going to be fairly interactive, I hope. And but before we get going, I think I need to introduce to you my lovely daughter and also admin assistant. This is Meg. If you have any questions during the course of this masterclass, then pop them in the chat. Meg is on it. She will make sure that your voice is heard, as it were, even without being allowed, if you sort of mean. And that is our cunning plan. I am gonna get going, I think. No more reason to hang about. I suppose I ought to say that my name is Alison. Okay, I forgot to say that. So I'm Alison, and I am the owner of 42 Tutoring. I'm one of only two tutors that does tutoring with us. We only do A-level physics, so you're in the hands of specialists. Okay, right now I'm going to let's start. We're going to learn. Okay, you have to ignore my little robotic men. I got a little bit carried away. Anyway, so what you're going to learn, hopefully, in today's session, right, you're going to find out about this enormous task that you've undertaken, which is to do A-level physics. Now, I expect one or two of you might decide that after a couple of weeks, A-level physics isn't for them. And if that's right, then you should consider it. Think early rather than later. But lots and lots of you have made the decision to do A-level physics. And what I'm going to do, hopefully, is to transfer to you this idea about how much work it is you've taken on. A-levels are not easy, not any of them. But, well, you'll see, especially A-level physics. Right, this is where we start doing the interactive bit. I'm going to talk about the documents you need to have to hand and the importance of the data sheet and your specification. Now, there's going to be people from various different specifications here, and I am not going to do anything that's very specific to any particular exam board. In our tutoring, we focus on AQA, OCRA and EdXL. That doesn't mean that what we're going to do today won't apply to you if you are doing one of the other exam boards. I think the only ones I could see on the list were WJEC. There were a couple of people doing that, and there was one or two doing OCRB, which is the Institute of Physics Advancing Physics course. Really, really good course. Quite difficult to get good grades in. Which is why most schools don't do that one, I think. So really good from the point of view of the physics mind. Okay, so we're going to do something about the documents, and then we're going to talk about how you learn, how you consolidate, and how you revise. And I'm going to put inverted commas around revise because I don't think you should. I'll explain what I mean by that, and we'll talk about the learning loop when we come to item 3. Then we're going to do the importance of exam techniques and some examples of exam techniques. This is probably the single most useful bit of this session. So you need to have your pen and your paper ready to hand. Exam techniques is something that mostly doesn't get taught in schools at all, and consequences that lots and lots of people end up saying, well, I actually understand the physics, I just can't answer the questions. And that's where you can be really, really good at physics and still only score a C. So exam techniques. Then I'm going to do some advice for parents. And then, because I can't possibly introduce every aspect of A-level physics in an hour and a half or whatever this is going to be, I am going to offer my tutoring because obviously that's what I do for a living, and I would like to be able to offer that and give you an opportunity to invest in your education with us. But I'm not going to do it before the useful stuff. It's only going to be afterward. Okay. Now, there's one final thing, and that is if you stay to the end, you will get a free gift. But you do have to stay to the end. This is to encourage you to listen to my offer, obviously. But yeah, you'll get a free gift, and it's worth having. I'm not going to say anything more about that. Okay, so we're going to start off by putting things into perspective. Right now, this is really quite difficult to read because the text for the top page is all really rather difficult. But hopefully you can see there on the right hand side, it's actually fourth from the right, is physics. So this is A-level physics. So what this is, it's A-level subject by relative difficulty. Okay, so the easiest subjects are on the left, apparently, and the hardest ones are on the right. So you can see that physics is widely considered to be difficult. It's the fourth hardest. The ones that are more difficult are critical thinking, Latin, and further maths. I was talking to one of my students last week before, who was telling me that he thinks physics is harder than further maths. I think it depends how good you are at maths, but honestly, yeah, it's really difficult, physics. And on the other hand, really worthwhile having. So it is considered one of the numerate A levels. So chemistry, physics, obviously maths, further maths, economics, and physics, and that's pretty much it, really. Those are the ones that give your potential employers the idea that you actually like numbers, and lots of physics students, of course, prefer numbers to words. Okay, so physics is hard. You've already chosen a difficult subject. That doesn't mean that it's not worth doing, though. It will open a great many doors for you. More people did physics this year than last. It was about 35,000 students did A-level physics last year. This year the cohort was over 40,000. So we're looking at a lot of people. Put that in perspective, maths, which is the A-level that most people do, 100,000 people do A-level maths every year. So yeah, 40,000. I think it's sixth by number of people taking it, but overwhelmingly those people are boys, males. So it's less than a third. It was about 20%, I think. It's less than a quarter even. Girls, women taking A-level physics. So if you're a girl doing A-level physics, yay, solidarity. Anyway, right, okay, this next bit is about what you can expect to get at A-level based on what you got at GCSE. So this figure, it's all really rather complicated. I don't know if you can read, you might want to go and look it up. It's from Ofqual in 2017. And this diagram is based on the old grading structure, which is why I've got the old grading structure on the right hand side. I mean, it says current, it's not current. That's old now. The new grading structure is current. But anyway, this is a diagram to show you the distribution of A-level grades if you got a GCSE grade A. Well, of course, grade A doesn't exist at GCSE anymore. So can you see grade A on the right-hand side over here? Is a 7 or maybe an 8, okay? And a grade A star was an 8 or a 9, okay? So a grade A was a 7 or an 8. Okay, so if you got a 7 or an 8, this column obviously applies to you. So about a third of the people that got an A or a 7 at GCSE end up with a B at A level. And about a third, it's just actually a bit over a quarter, end up with a C. And about a third, can you see, end up, or just over a quarter, end up with either a D or an E, or maybe even a U. Okay, it's 15%. So 85% of people who got an A equivalent, a grade 7 at GCSE, won't get an A at A level. Okay, so beware that your natural space, if you got a 7 at GCSE, the natural progression will say that you're probably going to get a C. You might get a B, you might get a D, but probably you're going to get a C. What that means is that if you got a 7, or maybe even an 8 at GCSE, you're looking at a C or maybe a B at A level, unless you do something to buck the trend, to make sure that you are going to do better than on average is the normal progression from GCSE to A level. So this is something that you have to bear in mind. So not only is A-level physics really difficult, but on the whole, if you've got an A at GCSE, a 7, you're going to end up with a C at A-level. Unless you work really hard on the right things. It's not just working hard, it's working smart, so that you end up giving yourself an opportunity to improve on that. It doesn't mean that you can't. Of course you can. Of course you can. And if you've got an 8 or a 9, then your chances of getting an A or even better at A level is improved. Okay, so just putting things in perspective, though, grade 7, chances are you're going to get a C. There's a third of people will get more, a third of people will get less than that, ish. Okay, so bear that in mind. Right, so that's putting things in perspective, right? Okay, so basically physics is hard. Now the next thing I want to do is to show you a little bit of video from one of my students she wasn't actually this year, she graduated from me in 2024. So this is a bit over a year old, this advice. It still applies. Okay. Oh, no. Stop. Oh, it always does that. Right. If I start it from within the PowerPoint, it doesn't echo. Right. I'm going to start it again. Hopefully this won't do that. Okay. Start from current slide. Okay. I'm going to ask you one final question, and that is that if you could advise yourself kind of this time, but just before you started year 12. Okay. So just before you started your A levels, what advice would you give to yourself?
That is a very good question. I would probably say that for me, I found it at the start of year 12 quite a shock, like going from GCSE to A level. I think that's quite
a big step up, isn't it?
Yeah, so it took me quite a while to adjust to like the amount of work, but I think I would just say like keep going. Like you'll come out of it at the end like proud of yourself. Like it is worth it. At some points you think, is it worth it? But I think definitely, I don't know, keep going. Maybe try to come up with like a regular like studying like plan.
Okay.
Into like, regular structures, kind of what really helped me.
Okay, so regular work is what really helped her, and she was 3 marks of an A star. She got in to be a Dyson apprentice. So if you haven't thought about what you might want to do when you finish your A levels, Dyson apprenticeships are very well sought after. Anyway, okay, so that is Emily. She's lovely. Anyway, right, okay, so we're going to move on then from putting things into perspective. I'm going to talk to you about the documents that that are really important for A-level physics. Okay, there are 1 or 2 that you really need to get your head round. Okay, so the first one is the specification. Right, now I'm going to escape from this a minute, and I'm going to minimize that. And here we've got, this is my Google Drive. I've got all the specifications for all of the different courses that you might do at A level. And I'm going to pick on the AQA one, because the AQA one is the one that most people do. About 2/3 of the people that do A-level physics do AQA. So this is the AQA specification. And if I do the print button, it makes it a little bit bigger. Okay, so this is the AQA specification, and you should get familiar with this. This is obviously not my document. You can find it on the AQA website, and in the A-level physics bit, obviously. What you should do is you should, first of all, have a look at the specification at a glance. In other words, okay, specification at a glance. So you've got core content, and then there's option topics. WJEC also have option topics, but none of the other A-level exam boards do. So you've got the core content, everybody has to know that, and then you choose one option topic. I don't know anybody that's done the electronics option, so and most people do Astro, but you probably won't even find out which option topic you're doing until next year. Okay, so, and then can you see you've got the AS, and it tells you that it's a written exam. You're going to be examined on sections 1 to 5, how many marks it is, and how long the exam is. That's then AS paper 2. And in your full A level, can you see it tells you how you're going to be tested. And then the next bit is the content. Now, the subject content, this stuff, section 3, basically, I would print out this document. It's probably about 50 pages, it's quite a lot, and put it in the front of your physics file. This document, it's not really made for students to read, it's made for teachers to read. It's so that the teachers can see what it is they've got to teach. But it's written in English. And you're not stupid, you're nearly adults, and you choose to do A-level physics, so you're really not stupid. So this document tells you what you need to know. Now, that doesn't mean that they can't ask you about stuff that's not on this document. They can, but if they do, they have to give you all the information that you need in order to do it. So, and knowing what it is you need to know is a really powerful thing. So I would recommend that you print out your specification and adjust the content bit and put it in the front of your physics folder that you're going to use every day in school, in your lessons. Right, so that's the first document that you really ought to know about. The second document is the data sheet. Okay, whoever's drawing on the screen, can you please stop? Thank you. Okay, so we've got the data sheet. Now, at GCSE, they make you learn loads and loads of equations. At A level, they give you loads and loads and loads of equations. Okay, so the next one along is my data sheet list. Okay, so here is all the data sheets. Again, they are on the exam board website for your course. So you need to choose the one that's suitable for you. Well, I looked at the AQA specifications. I'm going to look at the OCR-A, which is the second most common exam board, for what they call it a data, formula and relationship booklet. Okay, and it's full of stuff. I mean, it's got physical constants galore. Okay, loads of those. It's got quarks. See, you don't know about quarks yet. You'll learn. Conversion factors for things that you've never heard of, like electron volts and parsecs, where you might have heard of a parsec from Star Trek or something.
Star Wars, and they've got it wrong. They use it as a anyway.
She says they get it wrong in Star Wars. Parsecs. Parsecs is a measure of distance, and it was about 3.2 light years. Well,
yeah, they use it as time because they're wrong.
Oh, they use it as time because they're wrong. Oh, well, I don't know. Anyway, there's some mathematical equations. Oh, the OCRA give you more maths equations than any of the other exam boards. Then there's all the relationships between the different things. But you will notice that these formulae, they don't define what the terms mean, what all the little letters mean. And this is really my first teaching thing for you. I mean, I've been teaching already, but this is actual physics, right? All of these terms, all of these variable letters, they're all used more than once, which means that, and it doesn't say what each of them mean in these equations, and it's not always clear. If they're used more than once, well, hang on a minute. Okay, so I'm just going to point out one or two for you. Okay, can you see that T there? It's 1 over F, which is the frequency. So that T is the period. Okay, so that's okay. That's all right. T is period. Okay, you're used to that from GCSE. Okay, if I keep going down. Okay, that T there, and that one, and that one, those are all temperature. Capital T for period and for temperature. Okay, so so we've already used it twice. There is another T. Have we got it? At the beginning. Where's the wave stuff? There it is. Oh, of course, I've forgotten. You don't get that equation for OCRA.
There's a little t.
Yeah, there's a little t. Little t is nearly always time. Little t is nearly always time. So what I'm going to do is I'm going to open up the AQA datasheet, and in here, there is yet another T. Okay, so this one. Can anybody tell me what that T stands for? You get a gold star if you can put it in the chat. What does that T stand for? This one is period. But that T there, what's that T?
Tension of strain.
Yes, it is tension.
Oh, another tension.
Okay, so yes, excellent, right. Okay, so clear all my drawings. Right, so what I'm going to get you to do now, I'm going to give you a few equations, okay? So what I'm going to do is I'm going to put this one over here. Oh no, I didn't want to do that. There. Thank you. And on the right hand side, I'm not going to have my question sheet yet. I'm going to have that. Okay, so let's have my equation sheet on the left. So what I'm going to do is I'm going to give you an equation and you have to tell me what the symbols stand for. So you've got no context. There's no, in this question or a diagram or anything that you can refer to. It's just an equation. What do the symbols stand for? Now, these are going to be based on GCSE, so hopefully you'll be able to do this.
Wave speed.
Okay, so V, yeah, absolutely. Give them gold stars if they say V is speed.
Wave speed. F is frequency.
Good.
Velocity, frequency, wavelength. F frequency.
Here we go. Lambda is the wavelength. Well done.
Speed equals frequency times wavelength. Wave speed, frequency, wavelength, frequency. Lambda. Everyone's got it right.
Excellent. Okay, good. Right, so now this is the wave equation, and this is the GCSE version. On the left-hand side, there's the A-level version. What does C stand for? Obviously F and lambda are the same.
I know. Me. Oh, we've got a couple answers. Hang on, I'm still giving everyone gold stars.
Probably wave speed. I love that answer. You are so right. You are so right. Okay.
And
It is wave speed.
What kind of wave?
Light. It is. It's the speed of light. Okay.
Everyone's putting the speed of light. Wonderful.
Okay. So the speed of light then. So this is the wave equation. And you can see that the speed of light is f lambda, is a special case of the wave equation. Okay, so this is a special case. Okay, and it applies to all electromagnetic waves in air or in a vacuum. Okay, if you've got your electromagnetic wave going through something like glass or water, then it goes slower, and that's why it bends. That's refraction. But anyway, okay, so there we go. So we've had one example right now. Is it on there? Oh, it is on there. It is on there. Right, okay. I'm going to give you two equations at the same time now. So there's this one. I want to know what those three stand for. And there's this one. I want to know what those three stand for.
Ooh. Okay, we've got W is weight. Someone's put work. Weight, mass, gravitational field strength. Weight, mass, gravity. M is mass. Weight, mass, gravity. Weight, mass, gravitational field strength. Weight equals mass times gravity. Weight, mass, gravity. Weight, mass.
Okay, everybody's getting this right.
Oh my god, so much.
So many people are getting this right. That's very, very good. Okay, right now, the first W, the red one, is the weight. Okay, and this is a force and it's measured in newtons, right?
Indeed.
M is mass, and that's measured in kilograms, and G is, well, gravitational field strength, or we're just going to write gravity. It's got two lots of units, people. Mm-hmm. It's got two lots of units. It's either meters per second squared, because it's the acceleration due to gravity, or it is newtons per kilogram from the weight equation. So that is the weight equation. Right, now, the blue equation, on the other hand, this W stands for work, okay, which is measured in joules. F is the force, which is measured in newtons.
We're back to Star Wars again.
D is the distance. Oh, back to the force, yeah. Distance. Right, now, this again, this blue one, this is the GCSE equation. Mm-hmm. So this is the work equation. And I always remember it as work for dosh, because you work for your money, don't you? Except, of course, the A-level equivalent equation for that work equation is W is equal to Fs cos theta. What is the difference between S in the A-level equation and D in the GCSE equation? What is the difference?
Oh, you're telling them to check stuff. I haven't finished giving people stars yet.
Oh, I'm sorry.
I've got so many messages already. Hang on, I'll have to come back. Displacement is a vector quantity.
Yep.
When the force is inclined from an angle instead of angle.
Vector.
Displacement, vector.
When the force is inclined at an angle. Right, the theta, what does the theta stand for? So we've got this idea that it's an angle. Okay, S is not distance. S is not distance, it's displacement. What's the difference between displacement and distance?
Oh gosh, I'm going to get more. Displacement is a vector.
Perfect. So displacement is a vector, distance is a distance. It's a scalar. Okay, so S then is our vector displacement. Okay, D is distance. Okay, both of them measured in meters, but displacement has a direction. So in our bottom equation, this is our A-level equation. If you have, for example, okay, you're pulling something along So here's somebody, and they're oh, it looks like they're pulling it with their teeth. But anyway,
Just a really long ponytail.
Yeah, somebody's pulling it with their teeth. Right, they're moving this object. There's friction and all sorts going on, tension in this string, and this is obviously some sort of power guy that's doing it with his teeth. But anyway, okay. So what we're doing is we're pulling that heavy block across to the right. Okay. Now the displacement that it has. Okay, so it starts there, and let's imagine that it ends there. That's where it ends up. Okay, do you do that? Right? So the displacement is there. That's S, isn't it? But can you see that the force is up? So, and the angle that we're talking about is the angle between the displacement and the force. So it's only, in effect, what's called the horizontal component of the force in the direction of the distance moved, or the displacement, that gives you work done. Okay, this is why it's only when you lift weights up that you do any work. If you just move them sideways, they don't really do any work. Okay, right, we're going to clear all
So this
of those.
is always for horizontal components?
Oh no. Oh no. It just depends where they put the angles. Okay, so if you have that A-level equation, and we've got two vectors, these are disparate vectors. One is the force vector, okay, and the other is the displacement vector. Theta is always the angle between them. So you can either consider the component of F for Freddie in the direction of S for sugar, or you can consider the component of S for sugar in the direction of F for Freddie. It doesn't matter which way round you do it, that you end up with the Fs cos theta equation. Okay, so it's the angle between those two things, and because it's the adjacent, cosine is the trig function, the ratio that goes into that equation. Okay. So I'm sure that people will explain this to you when you do work, and I'm hoping that you will remember this little bit of learning that you've just been doing today. So yeah, it's not always cosine for horizontal. Sometimes it's going up. Okay, right, now the next one I want to do then is this equation. Hopefully you will recognize this one. So we don't get to use the generic GCSE work done formula. Yeah, you can. Of course you can. When theta is 0, cos theta is 90. So when F and D are lined up, or F and S are lined up, yes, you get the GCSE work equation. Yes, you do. And you can use it.
And then you don't have to plug in loads of different numbers for no reason.
Anyway, right, what does F, M and A stand for?
Me, I know.
Hopefully.
Oh my god, everyone's done it.
Everybody knows this one.
Someone has put resultant force.
Oh, I love that. Right, that person gets gold star. Okay, resultant force. F is resultant force, or the net force.
Someone's put Newton's second law.
Good. Okay. It's not how Newton said it, mind. Okay, M is mass and A is acceleration. Was
Newton wasn't English, was he?
Yeah, it was.
Was he?
Yeah.
Oh, I'm just remembering things wrong.
Sir Isaac.
Yeah.
So Isaac Newton. Yeah, he was
Why did I think he was Italian? I don't know.
I don't know. Volta was Italian.
Oh, that's probably right then.
Ampere was French. James Watt, Scottish. Anyway, right, okay. So F equals ma. So F is resultant force, M is mass, and A is acceleration. Okay. Newton actually said this. He didn't say F equals ma. He said that impulse is equal to change in momentum. That's what he said. Yeah, instantly forgettable. Yeah. Okay. So but we've also got the definition of acceleration, which is the rate of change of velocity. which means that we can do the classic thing, which is to substitute that bracket in there for A, and we end up with a new equation that's really another statement of Newton's second law, which is m v minus u over t. Okay, right, now I'm going to give you some new knowledge now. Okay, so the blue equation is another statement of Newton's second law.
Isn't that Suvat? Someone said.
Yeah, the A, A is equal to V minus U over T. Yeah, this is for it in a straight line. Yeah, so that's
so
that's
much of
Suvat.
physics is Suvat equations.
Yeah. Okay, so yeah, well done. Sophie gets the star.
I've already given it.
Oh, sorry, I'm slow. But anyway, right, okay. So what I'm going to do now is I'm going to multiply out my bracket and I'm going to put my t on the other side. So I'm going to put ft there, and then I've got mv minus, oops, can't write now. Oh, come on. mu on the right-hand side. So now this thing, I want to know what it is. And this thing, I want to know what it is.
Oh, force equals change in momentum over time.
Yeah, that's that one. I quite like that, Rishi. But this one, I'm going to put it in a, let's have it in an orange box. What is the left-hand bracket? What's that called? And what's the right-hand bracket? What's that called? It's not work done. It's not F times D. It's F times T. Oh, it's different. Oh, it's different. Does anybody know what it was called? Easy mistake to make, isn't it? It's just one letter, right? Different. Same. Impulse! Okay, so this then is called impulse. So it's the force times the time. I like to think of it as follow through. So when you're doing football or cricket or any racket sport or, golf, if you follow through, if you manage to keep your force transferring object, like your bat or your foot or your a tennis racket or whatever, in contact with the ball for longer. Imagine that you manage to keep it in contact with the ball for twice as long because you're following through. So T is twice as big because that's the time for the impact, right? Then you double. What's on the right hand side? Oh, I've got 5 new.
Yeah, I had a few questions of...
It's not work done. What's m times v? Momentum. So what's mv minus mu? We're back to Suvat. V is my final velocity. U is my starting velocity. So it's initial momentum and final momentum, absolutely. So if you've got one minus the other, what is it? Zara's got it. It's and Pfizer.
Yeah, and change.
Yeah, it's the change in momentum. This is the change in momentum. So force is defined as rate of change of momentum. Impulse is change in momentum. And I'm going to give you, I'm going to give you a big clue, because in your exams at the end of this year, you will get, without a doubt, a force time graph in one of the questions, at least one. Okay, so you're going to get a force time graph. Okay, and it'll do something weird, right? Force time graph, right? The area under the force time graph is force times time for each of those itty bitty little times. And so the area under your force time graph is your change in momentum. Okay, I'm going to tell you now, that is going to come up in your final exam this year. Integration, it is indeed. Okay, and we come on to another topic, really, don't we?
Well, before you move on to topics, someone did ask, what is Suvat?
Oh, Suvat is just the name given to motion in a straight line. Okay, so there are 5 variables, and they are given the letters S, U, V, A, and T. S is displacement. U is initial velocity. V is final velocity. A is acceleration. And T is time. And you are familiar with this because at GCSE you have to know this equation, which is the definition of acceleration. It's a rate of change of velocity. So it's the change in velocity divided by time. The rate of anything is that thing divided by time. Okay. And the other one that you have to know at GCSE is this one. You have to know it. I don't really know what AS levels are and how they work.
Well, don't really have AS level anymore, do they?
Yeah, you can do AS. You can do AS. Oh, so after a year, so you've got your GCSEs. That's okay, no worries. Yeah, AS level, it's like half an A level. It's like, so after your GCSEs are considered to be a, I think they're a level 1 qualification. I think it's level 1. And then AS, which you normally would do, most people don't do them, but normally you would do it after 1 year of A-level study, and that you get an AS, and that's a level 2 qualification. And then after 2 years of A-level study, you do your full A-level, and that is a level 3 qualification. Okay, and you can keep going. Your first year of your degree is a level 4. Your second year is a level 5. Your third year is a level 6. So a master's is a level 7. And it keeps going, okay?
Oh, apparently you got it wrong. GCSE is a level 2.
Oh, okay. So so AS is not a level 2. GCSE is level 2, and yeah, okay.
Thanks, Nick.
Thank you very much. Yes. Okay. So so it's just between GCSE and A level is what AS is. So if you decided after a year you didn't want to carry on, you wouldn't have to go, well, I'm just going to throw all that effort away. You could do an AS and get a qualification at the end of it. And ASs do give you UCAS points, so you can use them to help you get into the university of your choice. Okay. Right, we are going to stop doing data sheet. Let's identify the equation thing, because I'm never going to get on with this. So the next thing I wanted to do was I wanted to talk about the textbook. Right now, I would hope that every single one of you will get a good textbook that is relevant to your specification when you start your A level. You might not be allowed to take it home. If you can afford it, then I suggest, if you can't take your textbook home, that you buy one. You can buy them secondhand on eBay and Amazon, and they are, although they're reasonably, they're not that expensive, sort of 20 quid for a textbook. So not brand new, but for the latest specification would be a good idea.
You might be able to find them at the library as well.
Yeah, you might be able to find one at the library, but of course you then have to pay fines if you don't give it back.
Well, I've never.
So
I mean, you can do the work at the library as well.
Oh, I suppose so. Right. Okay. Right. Now, the next thing I'm going to do is I'm going to give you a free textbook. Okay. So on your chat, I'm going to put in a copy of a textbook which is called College Physics Open Stacks. Okay. It's a free, open source, free, copyright free textbook. Okay, and it's so you can use it, and it's absolutely fine for me to give it away, because I'm not what's the word?
Charging. Yeah,
I'm not charging anything for this, obviously. So let me minimize that, and I want to maximize that. So I'm just going to pull this. Oh, no, I got it up. This one, right. So this is, I hope you can see it, the blue is quite pale. This is the textbook that is in the link. It's a PDF. I've actually given you the PDF of this document, okay? But if you look at it online, you can see that all of these titles for the contents I mean, it's really pale blue. I hope you can see that. But they're clickable. So you can just click on it and go to, right now, this is American. Okay, just beware. This is includes things that you don't need to know. Okay, so this is why you have to have your specifications so that you know what you need to know. Okay, so but it's actually not bad. So projectile motion, for example, if I click on that, come on, why don't you do it? Oh, it's stopped. There we go. Projectile motion. It's just very slow. Okay, so and these are the equations. Oh, they've got dots and double dots and things. So they use X instead of S for sugar. So so there you go. It's quite an advanced textbook, but it has got everything in it and some more stuff that you don't need. Okay, there you go. There's an example of a trajectory of a rock ejected from a volcano, which is nice. You can't find the link. It is in the chat.
It's loading.
Oh, it's loading.
It's got to upload.
Right. If you are in the WhatsApp group, I can add it to the WhatsApp. So this is. I hope this is the right WhatsApp group. Is it? No, it's not the right WhatsApp group.
You've got to close that.
Really would be bad. Right, let's put it in the right WhatsApp group. Right, so it's in the WhatsApp group, the link.
Can you scroll back up on the chat just so that I can see how much time is left on it? Keep going. Keep going. There you go.
Oh, it's still not loaded on the Zoom chat. The other thing that I can do is I can do this. Hang on. Right, this link, it's a Google Drive link.
Is that where you got it from?
Well, I downloaded it and uploaded it to my Google Drive. So the link that I've just put into the chat will take you to the PDF that's in my Google Drive. You won't be able to preview it because it's too big.
There you go.
You'll have to download it. Okay.
It's finally uploaded on the chat.
Anyway, having a decent textbook is worth having. Okay, so there we go. So that's what I wanted to say about textbooks. Right, let's move on to the next bit. Right, now the last bit is about past papers. You need access to lots and lots of past papers. If you get any of my courses, then you'll get access to more than you can shake a stick at. I think Brian and I, between us, Brian's the other tutor. I think I mentioned him, didn't I?
At the very beginning, you said
at the
that
beginning.
You were one of the tutors.
Brian and I, we've got over 3,000 papers, I think, now. We've got, anyway, you've got access to not just the current course, but all the previous courses. The current course, past papers, you will be able to find all except for the most recent ones on your exam board website. So please, please, please go out of your way to have a little look at your exam board website. There are papers from previous examinations, specifications. The most recent specification prior to the current ones, which started well, for AS in 2016 and for full A level in 2017. That was when it was first examined. So you've got a reasonable number now. The previous specification, the main difference for A-level physics between the previous specification and the current one is how they examined the practical. Okay, so please be aware that the practical examination in the theory papers now is more taxing than it used to be, because they used to do a practical exam under exam conditions with kit, and you actually had to make measurements and count numbers of oscillations of pendulums and things. They don't do that anymore, except in Ireland, and so just be aware that actually the previous specification, all of the papers are relevant, the content is almost identical. to the current course apart from the practical. Okay, so that's worth knowing as well. You do need lots and lots of past papers. Obviously, you want to start with AS papers, and obviously you can't do that yet. You've got to learn some physics first. But as soon as you possibly can, I would get on to answering papers. And that's because, let me actually start my slideshow. Okay. Right, so, and that's because you need to figure out, well, how to learn in the first place, and then how to revise. And I'm going to talk to you about my learning loop. So there are loads of teachers around the country, and they think that their task with A-level physics is to transfer from their head and their textbooks into your head and your textbooks all of the concepts to do with A-level physics. Okay, and that is their task. And so day in, day out, week in, week out, in your A-level physics lessons in school, your teacher's going to be telling you about physics concepts. And that is brilliant, and that's what they should be doing, and that's great. And so what I would suggest you do is that you pay attention, you listen, you do the exercises that they ask you to do. So you start off with summary questions, and then you go on to proper A-level questions on that topic, and you start to learn how the various different bits of physics interact with each other, and so on. So you need to do all the things that your teachers have told you to do. When they give you a test and you've got to revise, that is when you are going to do questions. And the reason I think that you should do questions rather than anything else is because in your A-level and in any test that your teacher gives you, the only thing that you have to be good at in order to score well is being able to answer questions. And nobody is good at something if they don't practice it. Okay. Now, maybe when you're revising for tests, when you revised for your GCSEs, you've just all of you done some really stonkingly hard exams. Okay. Maybe you read notes on your notes, or you created flashcards, or you quizzed each other, or you watched videos, or BBC Bite Size, or you did questions out of your textbook, or you I mean, there are lots and lots of different things. You could make up songs and dance to your equations in physics. There's all sorts of things you could do, but there's only one thing that you need to be good at in order to score well in the GCSE, and that is answering GCSE questions. And the same thing is true in A-level. If I said to you, I've entered you into the London Marathon, and you go, ooh, okay, well, maybe one or two of you are marathon runners, I don't know. But let's imagine that I've entered you into the London Marathon and you're not a marathon runner. What would you do to prepare? Would you watch videos on how to train? Would you watch videos on nutrition for marathon running? Would you create flashcards on exactly how to move your limbs when you're running? What would you do? What would you do? This is not a rhetorical question. What would you do to prepare for the London Marathon?
Run.
Yeah, you'd run.
And run.
And you'd run, and you'd run, yeah, absolutely. You'd start off with little runs and you'd get longer and longer, wouldn't you? And yeah, sure, you would pay attention to your rest and your, maybe you'd do some other training, and you would also, keep a track of things, and you would look at your nutrition. You would do other things.
Learn your route.
But you would have to run, okay? There is no alternative to lots of running. Okay, and it's the same if you're learning to play the piano or a foreign language. You've got to actually be exposed to the language. You've got to talk to people. Language is about communication. You have to talk to people. So marathon running is about running. Playing the piano is about actually making noise with the keys. You can't do it by watching videos. So it's very tempting, and this is what happens to lots and lots of students. They think that if they pay attention in class and they do their homework, and you know, they maybe watch a few videos or make some flashcards or something when they're asked to revise for a test, that they're actually working hard. And the truth is that probably most of what you revise, most of your flashcards, most of your writing notes on your notes or watching videos, what you're doing is you're reminding yourself of stuff that you haven't forgotten. So it's literally a waste of your time. What you've got to do is you've got to focus on the things that you don't know when you're revising. It's different when you're learning it in the first place. That's what you should concentrate on, and you should follow your teacher's instructions actually in class. But when you're revising, lots and lots of people, it's really hard. A good teacher keeps you right on the edge of what you know in class, and virtually every lesson you learn something new. Certainly every A-level physics lesson you do. And that's a really uncomfortable place to be. And you come home and you think, oh, I've got to revise for that physics test on Tuesday. And you don't actually do the things that makes your brain bigger, because that's hard. So you just sit down and you watch a video on it. Veritasium, they're really good, those videos. Z Physics is good. Physics Online is good. They're great. They're not going to improve your score in an exam. What will improve your score in an exam is doing past paper questions. You're going to have to start with A-level questions which are separated out by topic. There's loads and loads of them on the Physics and Maths Tutor website, A-level as well as GCSE. I'm sure some of you have used those at GCSE. Or you could come on my course and I give you more than you can shake a stick at. But you do it by topic question, and you need to start with proper A-level questions as early as you can, and you do some questions and you mark them yourself, or you get your teacher to mark them if your teacher's willing, and you then look at what you did wrong. So where you didn't score maximum marks, what was it that was wrong that stopped you from scoring marks? And now this is the bit that most people get wrong, because when you can't do an A-level physics question, you think to yourself that you can't do the physics. And I promise you that's really not the thing that causes most people problems. Most people can do the physics. All of you have got brains the size of a planet. No one takes A-level physics if they're stupid. Nobody starts on this road if they're not clever. Okay? Actually, understanding the concepts is only part of the journey. What you've got to do is you've got to learn exam technique. You've got to learn that there are patterns, not just in the numbers, but also in the words that are used to ask you questions in A-level. Okay, I'm going to give you an example. The example I'm going to give you is the word determine. Okay, now in some A-level physics questions, quite a lot of them in fact, the command word, the thing that tells you what to do, is calculate. Okay, and that's great. That's fine. Everybody understands what calculate means.
It means using a calculator.
Yeah, it means using the numbers that they've given you in the question to work out an answer, and you actually have to calculate it. Okay, you do a sums. Okay, then hang on. So then what you have to do is the word determine. Well, it says determine, I don't know, the speed of the car at t is 2 seconds or something, right? And you think to yourself, hang on a minute, okay, isn't that the same as calculate? Does anybody know when they use determine rather than calculate in questions? Has anybody got any idea? I promise you that it's almost like a code word, determine.
Justify?
No, it's not justify. No, that's a different command word entirely. To come to a conclusion? No, again, you sort of do because you come up with an answer. It's a calculate. No, it's not even proof, you see. You think that you understand what it means. No, they use determine when you have to get the numbers that you need to use in your calculation from a graph. So determine's exactly the same as calculate. You get marks for working, and you get marks for getting the right answer. But the way you get your numbers from, instead of being given to you in the question or in a diagram, it's from a graph. So you might have to determine, for example, the acceleration of the car at t is 2 seconds. And actually that's the gradient of a velocity time graph. And you've got to draw a tangent at t is 2 to the curve that's on the graph. And then you've got to get the gradient of the tangent. And that will give you the acceleration of the car at t is equal to 2. And you've determined your answer from your graph. Determine is always get your data from a graph. It's a code word. Now, there's all sorts of things like that in A-level physics, and you've got to figure out when you do your practice questions, right, did I get this one wrong because I didn't get the physics, or did I get this one wrong because I don't know how to answer an explain question? Okay, so, and there are lots and lots of exam techniques that you need to get your head around. Right now, I mean, I know loads and loads of people who are really clever, and they, I mean, for example, there's a girl called Michaela. She did her A-level this summer, and when she came to me, it was after Christmas. It was just before Easter in year 13, and she was on a B. So bright girl, but she was on a B, and she came on my Easter course where we focused in on exam techniques. We focused in on the things that you can figure out just from the way the question is written and the words that you use and how it's set out. And she moved 7 days, that Easter course was, just seven days. And within 2 weeks of the end of the Easter course, that's all she did. She didn't do any other tutoring with me. She was on an A star, and she got an A star in her exam. So exam technique can take you from a B to an A star in 3 weeks. And what I'm saying to you now is that you have got to get your head around the exam technique early. So you never go through that, oh, I understand the physics, but I can't answer the questions bit, which is really demotivating, and you end up with much lower grade than you expect to get at Christmas. Either just before or just after is usually the first time that year 12s get good grades graded. Yeah, right.
And it can make you worried about doing the exam in the first place.
Yeah, it makes you very worried if you're not able to answer questions. So it's exam techniques that is the key. That's what I'm telling you now. Right, so where's the questions? So when would be appropriate to watch videos and making notes, or should you just not do that altogether? Right, so when you're learning something in the first place, that's when you watch the videos. And if you have a question that you can't do, and it's the physics that you got wrong, not the exam technique, I don't know how to answer explain questions, but I really didn't know what it was that caused this to happen, and so I couldn't explain it. So that was physics that you got wrong. A video on that will actually improve your grade next time you come across a question where you have to explain that bit of physics. That will then help you. So you've got to be aware of whether or not what you don't know is physics, or whether or not what you don't know is exam techniques. You've got to be aware, and most people who do A-level physics, they're not aware, and some of them only become aware towards the end of year 13, and you don't want to be in that position. You want to get your head around it early if you possibly can.
And then the other half of it was, so could I use them to consolidate my learning then?
Absolutely, you can use it to consolidate learning. Yeah, if you're tired and your mum says you got to go and do some revision, and you go, oh, be aware that it's probably not going to make much difference to your grade, but you can go and watch videos. I don't mind. I don't mind. Right, okay, let's move on.
Well, it's also a good test. Without it being a past paper, is a good test to see whether or not you actually knew as much as you thought you did.
Yeah, obviously, you're testing yourself all the time when you're doing past papers. Right, so...
No, I mean watching the video.
Oh, watching the video, yeah. Okay, so now the next thing then is learning loop. Okay, so this is the learning loop. So this is not the same as learning the physics in the first place. This is when you are revising, preparing for an exam, I prefer to say, okay? So there's 3 steps, okay? So the first step is to do a past paper question. And you use that to do the second step, which is find out what you don't know. And like I say, it might be physics that you don't know, or it might be exam technique that you don't know. So you've got to use your past paper question to find out what you don't know. So you do past paper questions, you find out what you don't know. And then the really crucial bit that most people skip when they're just doing past papers after past papers after past papers, they skip this really crucial step. You've got to fill in the holes in your knowledge. So you do past paper questions, you find out what you don't know. Is it physics? Is it exam technique? And then you fill in the holes in your knowledge. So you have got to learn the patterns for the structure of an explain answer, the structure of a describe answer, the structure of a compare answer. Discuss, assess, justify. Actually, the ones that are really, really common is explain and describe. If you can do those and calculate and all the ones to do with calculate, like determine and deduce and show that, right? If you can do those, you've probably covered 80% of the questions that you're going to get in your A-level. So it's not that many that you've got to get your head around. Okay, so this is the learning loop then. Past paper questions, find out what you don't know, fill in the holes in your knowledge, and then you go back and you do more past paper questions. So you do a paper, find out what you don't know, fill in the holes. Do a paper, find out what you don't know, fill in the holes. That's the learning loop. And the more times you go around the learning loop, and if you do the crucial bit, which is filling in the holes in your knowledge, your grades will go up. If you don't fill in the holes in your knowledge, then although doing past papers will give you practice, which is also essential, it's not going to improve your grade as much as you hoped. Okay, so that is how to learn. Okay, right. Learn your data sheet then. And I don't mean learn the equations, I mean learn what all the symbols mean. So when you're going through and you're learning new topics, make sure that you know what all the symbols for that topic are for all of the equations on your data sheet. So you've got to learn your data sheet. You need to know what you need to know. So look at your specification frequently until you're familiar with it. Okay, this is a useful thing. Okay, is use your engineering button. Right, I'm going to stop sharing that a minute. Now, how many of you have noticed this is wearing off? I use it so much. There's a button here. Oh, can you even see that? It's called ENG. It looks like FNG because my E is wearing off. Okay.
And it doesn't mean it's going to write it in English.
No. That button is the engineering button. And what it does is it converts the number that's on the screen into engineering notation, which is a bit like standard form, except that the times 10 to the bit is always in factors of 10 to the 3. So it's 10 to the 3 or 10 to the 6 or 10 to the 9 or 10 to the 12 or 10 to the minus 3 or 10 to the minus 6 or 10 to the minus 9. And what that means is that you can easily convert prefixes, things like micro or milli and mega and giga into numbers. So if you, for example, have a question that says the frequency is I don't know, 5 times 10 to the 6 hertz, right? 10 to the 6 is mega, so you can say, well, it's 5 megahertz, right? Or if you were given a number that is like 5.3 megahertz, you can write 5.3 times 10 to the 6 and it's now in hertz. If it was 5 millimeters, you could write 5 times 10 to the minus 3 meters. Can't do it if it's squared, if it's an area. Can't do it if it's cubed, if it's a volume. But you can do it if it's just a straightforward conversion. So megajoules or I don't know, I'm trying to think of it. I mean, the obvious one for big numbers is gigabytes, terabytes, petabytes. That's the next one. That's 10 to the 15 bytes.
Well, we can go to particles then, and then you can end up with picometers.
Picometers, yeah. Yeah, femtometers is a sensible one. 10 to the minus 15. Femtometer is a typical size for the nucleus of an atom,
Yeah,
but a whole atom, including the electrons, is around about 10 to the minus 10, which it's not pico and it's not nano. It's neither. It's in between. So it's just annoying. But anyway, okay. So use your engineering button then to change from 10 to the 3 into prefixes and vice versa. If you get a number that's a stupid long number, if you press your engineering button, it puts it into factors of 10 to the 3 and you never have to count decimals again. Okay, so never count decimals ever again. Use your engineering button.
Error is so easy.
If you press it more than once, it shifts it and changes the prefix for you. And if you do shift in it, it goes back the other way. Okay, so have a play with it. If you've got an engineering button on your calculator, use it.
Yeah, learn your calculator.
Yeah, there's the engineering button. Oh, look, I had a picture. Why didn't I do it on here? There's
because you had a real life thing.
I had a real life one.
Also, it's not the same on every calculator.
No, I know.
Some of the new calculators, like graphing calculators that you can get now, sometimes it's in the settings.
Yeah,
which is weird. It's
true. Right. Okay. Let's move on. Okay. So that is the engineering button. Right. Check if you're on radians or degrees. Now, you probably don't know about radians yet. Radians is a different unit for an angle. Okay, it's used for circular motion, it's used for simple harmonic motion, which is where things are bouncing up and down or swinging backwards and forwards. Okay, you need to use radians then, and it's different to degrees. Can you see on this calculator there's a little D there? That means it's in degrees. You've got to be able to swap. Okay, you need to be able to change the unit.
And the difference between the two is big. So if you accidentally do it in radians when you wanted degrees, it's very wrong.
You'll get the wrong answer.
It's very wrong.
Yeah, so one radian, there's 2 pi radians in a complete turn. Yeah, it's not a whole number, which is horrible. Yeah. But two pi radians, and remember pi is about 3, which means that there are 6 radians-ish in a full turn. So actually 1 radian it's about 60 degrees. It's 57 degrees or something like that. So yeah, so radians are bigger than degrees, quite a lot bigger, 60 times bigger.
Is radians radians or radians?
Radians. Okay. So right now, this next bit, use a pale highlighter pen to highlight all the numbers in a question. This is part of my ninja question analysis. So one of the problems that people who are very intelligent like yourselves have with A-level physics questions is that you skim read because you're good at it, and it's a habit because you use it all the time. I mean, nobody ever reads every word in the TikTok caption, do they? You can read about every third word and still get the gist of it. Nobody minds. You can't afford to do that in an A-level exam. So, and using a highlighter pen to highlight all the numbers and various other things as well, it slows you down. And slowing you down means you don't skim read. It means you notice things more and you don't make as many mistakes. It means that you don't miss things. If you miss the words each second in a question, you get the wrong answer. Okay, so, and then energy each second is actually a power.
You are allowed to use highlighters in the questions, you're just not allowed to use them in the answers because the scanners won't pick up the colour.
Yeah, your question papers are scanned in, yeah, and the highlighter pens don't show on a scan, so you can't use it in your...
But you are allowed to use them in the questions.
You can use them in the questions, so I suggest you do. Right, read the examiner's reports. Lots and lots of people never read the examiner's reports. They tell you where most people went wrong. And I don't know about you, but I think that's useful information. Okay.
Because whether you like it or not, most people are most people.
Yeah. Right. Why is this not working now?
try turning it off and back on again.
Bother. Oh, right, let's try again. Why is it that it just does that sometimes? I don't know. Start from current slide. Right, okay, let's move on. Oh, look, I've done all this. Right.
Yeah.
Oh, okay. I just got annoyed then, and it decided it was going to do what I wanted it to. Okay, so the importance of exam techniques. Okay, so I've already done 2 of these. Perhaps I should go back. There we go. All right. Ooh. What? Okay. Very odd. Okay, right. Importance of exam techniques. Right, so we've talked a bit about exam techniques already. So the first thing is NQA and question structure. Okay, NQA is my ninja question analysis. Okay, so it's not reading, it's much more like trying to find the right piece of data in a table that's got masses of data in it. Okay, it's not like reading a novel at all when you look at an A-level exam question. Okay. The structure of the question also tells you quite a lot. So those bits are all really closely related to each other. Okay, and how many marks you've got, also really, really important. Quite often the very first question in any structured multiple part question is what I call a signpost question. So it might start off with define the principle of moments. Okay, or it might say, what are the 2 conditions for equilibrium? Okay, and if you give your 2 conditions for equilibrium, well, it's a big neon light going, this question's about equilibrium, you're going to need to use equilibrium in this question. Really, really useful stuff. Okay, so ninja question analysis, I will come to it. So we're going to talk about that just briefly. We're going to talk about command word scaffolds, and I'll explain what those are in a minute. And we're going to talk a little bit about problem solving. These are the 3 main things that people struggle with in A-level physics exam technique. So we're going to cover I can't possibly do it all, but we're going to do a little bit just to whet your appetite for each of these. Okay. So we're going to start off with our ninja question analysis. Okay. And this is where I'm going to escape from there and minimize that a minute. And this question, I hope you can see it, is the question. I want to get them where you put your answer on the screen so you can see how many marks there are. So we're going to look at this one right now. I've chosen this one because it's about moments, and you all have done moments at GCSE. So we're going to do the ninja question analysis technique, which is this idea of not skim reading. So we are going to get ourselves a highlighter pen. Here is my highlighter pen. And we are going to highlight various things within the question. Okay, so this is to slow you down. Right now, I don't want you to read the question yet. Not properly. Not for meaning. I want you to tell me, for question 12A, what is the command word? Find it and put it in the chat.
Ooh, we've got someone saying it already. Calculate.
Okay. So this is what you do. You highlight the command word. Right, so this is a calculate. Okay, we're going to do a calculate. You will discover that calculate questions are probably going to be your friend. Okay.
It means I get to use my calculator.
Yeah, calculate. Right, now, the next thing you're going to do is you are going to find all the numbers in the question, and you're going to highlight those. So I can't see any numbers in the text there, and I'm not going to, that one doesn't count. Okay, but that one counts, and that one counts, and that one counts. That one counts, and that one counts. I think that might be it. Oh, okay. So now, having found all the numbers, the next thing we're going to do is we are going to find the words that are numbers.
I know one.
Okay.
I can see one.
Okay. Can anybody see a word that is a number? Apart from Megan.
I'm not allowed to answer questions.
Well, I've got one there. There's a number. Okay. Okay, so can anybody find me some words that mean things that have physical, like, yeah, exactly said, like horizontal.
Zara did my one, which is negligible.
Where is negligible?
The weight of the beam is negligible.
Negligible, yeah, that means 0.
Yeah.
Okay, so we've got an upright support. Okay, we've got a uniform beam. We've got a negligible weight. We've got the bucket holding the water. We've got a uniform material. Okay, and we've got the beam is horizontal. Okay, so we've got, can you see we've got loads and loads, counterweight? Yeah, maybe. I mean, okay, so it's got a weight, hasn't it? So yeah, I think that counterweight counts. I think I like that. Okay, so far we've highlighted our command word. We've highlighted all the numbers. We've highlighted the words that are numbers. So, and now we've highlighted the words that have lots of physics meaning, like counterweight and horizontal and uniform, and the word like recoil or each second or at the same time. Okay, those sorts of things. Those are what you've got to highlight. Right, now what we're going to do is we are going to say what this question is about. So what is this question about? I want the name of the topic, please. Pop it in the chat.
Ooh.
Moments. There we go.
Yay!
Moments. Right. Now.
Someone said force. I mean, technically.
Well, yes, forces are part of moments.
Exactly.
There's nothing wrong with force except that this is more than just force because these are turning forces. Yeah. So moments is a better description.
Well, I think they got force from the Newton meters. At the end.
Oh, Newton meters, yeah. So it's newtons times meters. That's moments, though.
Yeah, I think
it's Newton meters, not joules, because it's not work, even though it's force times distance, because they're at right angles to each other. So there's no component of one in the direction of the other one. No work is done. Okay, just saying. But anyway, right. Okay, so this is about moments. So now the next thing you do in your ninja question analysis is you go and get your data sheet, which is in the front of your file along with your specification, isn't it? Or you've printed out half a dozen copies and you've got one on your bedside table where you do your work in your bedroom, and you've got one on the kitchen table if you work in the kitchen, and you've got one in your coat pocket so that you can read it on the bus on the way to school, and you've got one in the front of your file, your physics file that you use in your lessons, and you've got one on the back of the loo door in the toilet. Yes, absolutely. You are going to have a data sheet to hand all the time for the next 2 years. Okay, so you're going to open your data sheet to the equations on moments. Or whatever it is that the question's about. Right, so that's the next thing. And then what we're going to do next is we are going to read for meaning. Read for meaning. Now, when you are reading for meaning, you go really slowly. You read each sentence, and when you're reading it, you want to really draw the situation. Right, now we've got a diagram here already. We may not have to add much to it, but I am thinking that we ought perhaps to put a few forces on it. So we're going to add to our diagram as we read, okay? If you haven't got a diagram, then you draw an aeroplane with a man jumping out of it, or parallel plates with an electron between it, or whatever the situation is, right? So a shadoof is a device used to lift water from a well. It consists of an upright support, which is this thing, isn't it? There's my upright support. And it says a uniform beam is pivoted there. So, and it says pivoted, so we know that that's our pivot point. Okay, so the pink blob is the pivot point, P, okay? Pivot P, okay, good. Okay, it says it can be assumed that the weight of the beam is negligible. So the actual beam itself, we can ignore. Okay, it has no weight. It's like you know, no atmosphere to slow things down, or
spherical chickens.
Spherical chickens in a vacuum, yeah. This is one of the places where the really bright ones amongst you will make questions too difficult for you to do because you're clever. So you've got to allow for, you know, frictionless surfaces and massless bits of string and things that won't stretch and things that have no air resistance and things that have no friction. And here we've got a beam that has no mass, okay, no weight, okay. You've got to allow those to make the questions possible for you to do, because otherwise it's too hard. It's very easy to make your questions too hard for you to do. So don't do it. It's hard not to, okay? And especially if you're really clever, okay? Right, now it says on one end of the beam is a counterweight, okay? And that's the bit that the guy is holding. And on the other, a bucket which can hold water. Counterweight is uniform. What that means is the weight is in the middle. Okay, so I'm going to put the weight in the middle of my counterweight and I'm going to draw the force on it. So that is the weight of the counterweight. And although we don't know what it is, there must be a reaction force there, and I'm going to call that one R. And there is also going to be the weight of the bucket. Okay, that actually is the weight of that, it's the tension in the string. It works out to be the same as the bucket. So I've made that too long. I want to have that's the W. It's W for the bucket, but it's the same as the tension in the string. But it's caused by the weight of the bucket, so it works out to be the same size. Okay, so now what I've done is I've drawn the forces on my beam. Okay. And right, it says it can be assumed that the weight of the beam is negligible. One end is the counterweight, the other end is a bucket, right? And then it says the counterweight is uniform. It has a weight of 50 newtons. So this is equal to 50 newtons, okay? And it's 0.6 meters long. So can you see, if it's uniform, the weight is going to act in the middle of that. So it's going to be 0.3 meters from that side and 0.3 meters from the other side, okay? Right, now it then says calculate, there's our command word, the moment of the counterweight about the pivot when the beam is horizontal. Okay, so the beam is horizontal, everything's at right angles, which is great because our moments equation is that the moment of any force is equal to the force times the perpendicular distance from the pivot. So I've done D with this upside down T, meaning it's at right angles, right, like that. Okay, so this is the perpendicular distance. So what we've got to do is we've got to work out what that perpendicular distance is. I'm going to call that D, and we've got to multiply it by the weight of the counterweight. So what's our perpendicular distance? Can anybody tell me how to work it out? What is D? Because it's not 3.2 and it's not 0.6.
2.9.
Yeah, how did you do that, Rishi? You're right.
I think I know how she did it.
Yeah, it's 3.2 meters, which is the full length from the pivot to the end of the beam, minus half of the 0.6. So it's minus 0.3. I'm going to get rid of my M. You shouldn't put units in your equations. So that is the distance, that's D, okay, and we've got to multiply it by our force. So there, that is the sum we've got to do. Okay, right, now, I mean, you can do it if you want, but I want to move on. So this is an example, really quick, really dirty explanation of the ninja question analysis, okay, and there's various things that you can do if it's not a calculate question. Okay, so so there is one example, right? And now the next thing, if you remember, oh, actually, you don't remember because
okay, we've got two questions.
Is this a tricky question? No. Uniform means it's the same everywhere inside. If something is uniform, then what that means is that the weight is going to act in the middle.
in physics, but it's like at school you have to wear a uniform so everyone's the same.
Yeah, it means it's the same everywhere. Yeah, so if you've got a uniform acceleration, then the acceleration is constant. It doesn't change. And so, right now, is this a tricky question? Not particularly. It's not particularly. This is really relatively straightforward. After all, you've only just finished your GCSEs. And you haven't learned any physics yet. So I was just basing it on what you knew from GCSE. So fingers crossed, this wasn't too hard. But
it's an example question. It would be a bit mean to do a really tricky question as an example question.
It would. Okay, so that was my ninja question analysis thing.
For anyone wondering, it was 145 Newton meters.
Okay, right. The next one then is command word scaffolds. So now the next thing that you've got to get your head around is that each of the command words has got a structure to the answer. Okay, and the one there is explain. Right now, I want to talk to you about explain, because after calculate, explain and then describe are the two command words that come up more than anything else. So I have got an example question here, which starts off with sketch. So this sketch just means draw, but without any scales. Okay. The graph, the current voltage characteristic for a filament lamp. Again, I've picked things that I'm hoping that you'll remember from GCSE. A current voltage graph for a filament lamp looks something like this. Hopefully you'll remember that that's what it looks like.
Curved, indeed, Ramat.
Okay. So, and then, yeah, I know. Right, now, the next thing then is we've got two more command words that are the same. We've got state, what happens to the resistance as the current increases. Well, as the current increases, it gets hotter and the particles vibrate more and they get in the way. But state means just say what happens. You haven't got to explain it. So state is just give the answer. So the resistance goes up. That's what you have to do. You have to say the resistance goes up. You haven't got to explain anything. You don't have to describe the motion of the particles or anything. You just say what the answer is. That's state. There's no calculation required for a state. And we've got, then the next one, can you see, is state and explain whether a filament lamp is an ohmic or a non-ohmic conductor up to its working power. Now, ohmic conductors give you a straight line on an IV curve, and you get a straight line on an IV curve because the resistance is constant. And this one is not straight, it's curved, which is what Ramat told me. Okay, so it's not ohmic. That doesn't mean that it doesn't obey Ohm's law. Okay, what it means is that Ohm's law is this one, the very important rule. Okay, and everything obeys it all the time. It's just that if R changes with either I or V, then it's not ohmic. So it's not that it doesn't obey Ohm's law, it's just that the resistance isn't constant. Okay, so that's what is meant by ohmic. If the resistance is constant, then it's ohmic. If the resistance isn't constant, then it's not. Okay? Okay, right. We've got someone in the waiting room.
That's okay. No, they're coming in. I've already said they can come in.
Oh, okay. Sorry. I just noticed it out of the corner of my eye. Okay, so now this next one, this is quite hard to think about. So it's an electric circuit. There's nothing particularly difficult here, except that instead of just one bulb, we've got three. Okay, and we've got to do something which is, where's the command word, guys? Can you find the command word for this question? Yes, Raksha. Yes, it's explain.
Explain.
Yeah, okay, so we've got to explain. Right now, explain is the command word that most people struggle with. Explain has this structure for the answer. It's always the same. It's really simple. It's key fact, consequence. Now, in physics, a key fact might easily be an equation. So you might say, explain why the car accelerates. And you might then say in your explanation, well, F equals ma. That's a key fact, something we can all agree is true. And then consequence is, well, F goes up, so A goes up. And that's explain why the car accelerates. Okay, so now can you see that key fact consequence is easier for physics than for loads of stuff? I mean, it's still the same structure, even if you're explaining causes of the Second World War or explain, I don't know. Right, the one I always use in my demonstration calls, I do free demos when I talk to people who might want tutoring. And I always use the same example. Some of you might have seen this online. Okay, so explain why your bedroom carpet's wet. Okay, so your mum and your dad have said, explain why is your bedroom carpet wet? Okay, and you go, well, okay, key fact. There was a glass of water on my bedside table. It's obviously the key fact that's important, isn't it? Because it's the source of the water. Right, now, you get 1 mark for each key fact, right? So there's a key fact, which is the glass of water. There's a second key fact, and that is that you've got a cat called Derek. I hope there's nobody called Derek online, is there? I don't know. But anyway, cat's called Derek.
Too many people to check.
Okay, he's a very nice cat called Derek. Anyway, the thing is that Derek's typical of most cats, though.
Cat's been a cat.
Yeah, cat's still a cat. And Derek, you can see where I'm going. He knocks off the glass of water. So the explanation is, you know, explain why your carpet's wet. Well, key fact number 1, there was a glass of water on my bedside table. Key fact number 2, Derek got into my bedroom. And the consequence is he knocked off the glass of water and now the carpet's wet. And you can see that that's a 3-mark explain. I hope. Right, now, what it means is if you know that that's the structure of explain, then if it's a 4-mark explain, it's either 2 key facts and 2 consequences or 3 and 1. Okay, or 1 and 3. If it's a 2-mark explain, it's obviously a key fact consequence. If it's a 3, it's 2 of one and 1 of the other. Can you see? Suddenly it becomes easy to figure. Right, okay. Now let's look at our explain. The filament in lamp Q melts so that it no longer conducts. Okay, so this disappears. And our circuit becomes P R
Battery.
and a battery.
It becomes in series.
It becomes in series. Okay, so now Q was a second path for the current to take. And so a bigger current flows with Q there, believe it or not. You add in a resistor in parallel, the current goes up, the resistance goes down. Okay, so it says, explain why lamp P becomes brighter. Okay, now, this is difficult to explain. This is a potential divider circuit. Okay, the resistance of this bit has gone up because Q has disappeared, and the potential differences across the 2 resistors, which are bulbs here, is split the same way that the resistances are split. So if the resistance of P has gone up, effectively that bit's gone up, then the potential difference across that also goes up. It's a potential divider equation. Okay, so you can say that R1 over R total is equal to V1 over V total. This, by the way, is probably the thing in A-level physics in year 12 that most people struggle with. Most people have difficulty with this. But what it means is that if the resistance of the P bit of the circuit goes up, which it does when Q melts, the fraction goes up, and so the voltage will go up. And if the voltage goes up, it gets brighter. Okay? So But can you see? So when Q melts, right, the resistance of the parallel bit, I'm going to put P, goes up. That's a first key fact. This, I mean, you'd have to explain it in words, is the second key fact. And then the consequences, the voltage across P goes up and P gets brighter. Now, can you see that we've got our structure of explain? And suddenly, from being vague, it becomes, well, I've got to have that key fact. I've got to have that consequence. It's not vague at all. Okay, so explain is key fact consequence. Next time you're asked to explain something, notice the structure of what you're saying. You can join the key fact to the consequence with words like so or because or it follows or therefore or consequently. Okay, right. Enough. We're really short on time now. I've spent way too long on this.
Oh, so why do we use two key facts and a consequence for a 2-mark question, or how do we know how many?
Oh, right. Well, only because it was a potential divider, and that's one of the hardest ones. So yeah, really, it ought to be a 3-mark explain. Giving only 2 marks for that explain is just mean. Yeah. So yeah, if you can explain it in only 2 and it's 2 marks, then that's better. No, it's better.
It's basically a marker bullet point, really.
Yeah. Right, now, this last one is problem solving exposed. I do not, as a pleasure, I do not have time to go through this. Oh, do I? Do I do problem solving exposed? How much longer do people want? Right, say yes if you want me to do some problem solving, and say no if you don't. Oh, everybody's saying yes. Okay, we're going to do some problem solving.
Oh, someone very nicely said please.
Okay, so we're gonna do a little bit of problem solving, right? So the next one that I prepared earlier, okay, is
made from yogurt lids.
Okay, this one is this is a problem solving exercise. Okay, it's multiple steps. And we've got various command words, okay? So now we're going to start with, let's find the command words. Actually, let me see. Oh, come on. I can't do it now. There we go. Oh no, it makes no difference. Right, let's have the command words for A and B. What are the command words? Which command words can you see in A and B?
Define and state.
Yep. We've got define acceleration. What do you think this question's going to be about, guys? Yes, it's going to be about acceleration. Right, Sen, right, because acceleration is the rate of change of momentum. That's not wrong. It might be about momentum, but it's definitely going to be about acceleration. Okay? Yes. Okay, right, now we've got define, we've got state. Right, state, why is acceleration a vector quantity? Right, I'm going to say why is an explain. So that state y is really explain. So explain why acceleration is a vector quantity. It's a vector quantity because it has both magnitude and...
Give them a moment to type.
Direction. Okay, so yeah, that's your mark there for that one. Right, then it says state again. What feature of the velocity time graph may be used to calculate acceleration? Right, I'm going to draw a little velocity time graph. Velocity time. Right, let's make it do that, and then that, and then that. What is it about the graph that tells you the acceleration? Ramat's not got courage of his convictions. But you're right, it is the gradient. So you can see here that that's got a positive gradient. So it's got a positive acceleration. So it's accelerating in the positive direction, right? This one has got a gradient of 0, which means there is no acceleration. So 0 is acceleration, right? Here we've got a negative gradient. So the acceleration is in the other direction.
It is decelerating.
In the backwards direction. So, well, it's decelerating because the velocity is getting smaller. Can you see? So acceleration, I mean, you can either call it a deceleration,
or negative acceleration.
or yeah, you can just say that it's negative. Okay, so
whatever is easiest for you.
Yeah, okay, so
is deceleration getting slower? Yes.
So deceleration is getting slower, yes, right, or it's accelerating in the other direction, backwards direction, negative direction. Right, so now, what about this graph tells me the displacement?
Area under the graph!
The area under the graph, the area under the graph. Yes, absolutely, okay.
Area under the graph.
Now, those
the
of
bane of my existence.
Those of you who are doing A-level maths, you are going to learn that the gradient is the differential and the area under the graph is the integral. Now, you don't have to be able to differentiate or integrate for A-level physics, but if you understand the concepts, it makes everything so much easier. So, yeah, these are A-level maths concepts, even though it's GCSE maths for the sums. Okay, so right now, the next bit I wanted to do, this is the problem solving bit. Okay, so the graph in figure 1, there is figure 1. Right now, this is misleading. It is not, repeat, not a velocity time graph, even though they've just been asking you about a velocity time graph. Okay, this is a displacement time graph. Okay, and it says that it's displacement of a runner from a fixed point along a straight track and how that varies with time. Okay, so basically the runner starts at the beginning, 0 distance. Okay, it accelerates, gets faster, and then he goes along at a constant speed. What is it about this that tells me it's a constant speed between about 3 seconds and about 6 seconds? It's a straight line. Good. The gradient is constant. Okay. So we've got, what have we got? We've got here he's accelerating. Here it's a constant speed. What's happening here? I have to do them in different colours, shouldn't I? So there's the accelerating bit in blue, the constant speed in pink. What's happening in the orange bit? It's not stationary yet. Decelerating here, yes, absolutely. And then constant, perhaps you were ahead of me. Yeah, this bit where it's horizontal, that's constant. It's not moving anymore. The displacement doesn't change with time. So that means no speed, right? 0 speed. So the gradient of a displacement time graph is equal to the velocity. Okay, right, now we haven't got to the question yet, but I'm just making you look at this graph. Okay, right now, it says without calculation, sketch on the grid in figure 2 a graph to show how the velocity of the same runner varies over the same period. Okay, now I need really to have both graphs on the screen at the same time. Can I do that?
No. You could change the thing so that it's in page view mode.
I'm going to. Oh, that was a good idea. Oh, that's rubbish, isn't it?
So go in the little dots, I think you said. On the right.
Oh, there. 2-page view. Oh, it's the wrong way round though.
That's silly.
bother.
Oh, bother, how vexing. Well, how about you have an approximation of, you draw approximation of that one.
Okay, I'm going to draw an approximation of that one. So there is the displacement time graph. Okay, so that's time, and that's displacement S, okay, and that's 3 seconds, and that's 6 seconds, and that's 8 seconds, okay? So there is my displacement time graph. Right, let's go back to just one page view. And what we've got to do is we've got to draw on figure 2 a sketch of the graph. So we've got to turn our displacement time graph into a velocity time graph. That's the problem. Right, now when you're solving problems, you've got to figure out, right, ask yourself questions to figure out what you've got to do. So the question I'm going to say to myself is, what is it about the displacement time graph that tells me the velocity? Okay, can you see that's a question you've got to ask yourself. We're sketching on the graph, but it's quite difficult, this, isn't it? So it's the gradient of the green graph that's going to tell us about the graph we've got to put in. Okay, so can you see that gradient here in this bit, it's getting bigger. Okay, it starts pretty much 0 and it gets bigger. Okay, so I'm going to start with a velocity of 0, and up until 3 my velocity is getting bigger. Right, now I'm going to draw a straight line because I don't know that it's not, so I'm going to draw a straight line. Right, and then between 3 and 6 it's meant to be a straight line. That means that my velocity doesn't change. Okay, so actually let's do it, let's make it a bit taller. Let's make it a bit taller. My velocity then doesn't change between 3 and 6. Okay, so can you see it does something like that? And then between 6 and 8, what's happening? The gradient is getting smaller. Eventually it gets down to 0. So it does that, doesn't it? And then from 8 onwards, it's now not moving. Can you see? You've got to figure it out. So this is the problem solving. So when you're problem solving, right, you have to do all the ninja question stuff, and then you've got to ask yourself questions in order to figure out what you've got to do to get to the answer. And it might be here it's a graph. And can you see that the structure of the question points you in that direction? If I go back to here, can you see it says, what feature of a velocity time graph can be used to calculate the acceleration or the displacement? Can you see that they're saying, right, well, that's a displacement time graph. How do we get the other way to the velocity? So can you see they're kind of pointing you in the right direction without telling you the answer? So you've got to use all of the information. Right, I am now going to stop. Correctamundo. Lovely. Okay, I am going to stop on that. Right, so those of you, oh look, I've stopped sharing, and actually I want to go back to my where's my PowerPoint? There it goes. Right, those of you whose parents are within earshot, can you ask them to come along? Those of you whose parents are not in earshot, perhaps you could pop over and find them, because the next bit is about helping parents to help you guys through your A-level studies. Okay, so we've done the importance of exam techniques and a few small examples just to whet your appetite so that you realize quite how important it is. Now this next bit then is going to be advice for parents, so I hope that the parents are now coming back into the room. Okay, so advice for parents then. Some of this is fairly obvious, some of it less so. Okay, so A-level students, I mean, it's true at GCSE too, but even more for A-level, you need a quiet, comfortable place to work. And I would advocate practicing doing past paper questions under exam conditions. So no music, no phone, no interruptions, nothing.
No dogs.
Yeah, no dogs. We've got lots of dogs in this house. No dogs. Okay. Healthy snacks. So biscuits is great, chocolate biscuits, but after a while, yeah, you really ought to stick to healthy snacks. So
Bananas.
yeah, bananas, carrot sticks, that sort of thing. Okay, especially when you're in the run up to exams. Fitness, it's very, very easy, obviously not yet, but when you come near to your exam, to go, right, well, I can't afford to play football anymore, or hockey, or netball, or whatever it is that's I can't go dancing, I can't do rock climbing because I've got to revise, I've got to concentrate on my A-levels. You must continue to stay fit. The fitter you are, the better your brain works. And so don't give up everything. I mean, yeah, sure, temper it. If you go football training every night of the week, you can't afford to do that in the run up to your exams. But don't give up on everything. Sorry, excuse me. Oh dear. Okay, right, now, next then. If you start to struggle, your first port of call is the school. It's the school, it's the class teacher, the subject teacher, it's your form teacher, or your tutor, depending on what you call them, the person who is responsible for your pastoral care, it's called in school. You can ask for help from other students, you can ask for help from other parents, but really it's the school that you should seek help from. So if you start to struggle with homework load or with your health or mental problems, ask for help from the school in the first instance. They're really, really on your side.
The earlier that people know about problems that you could potentially have with taking an exam, or any kind of extra help that you'll need in terms of if you want to have a computer for the exams, or if you want
access arrangements.
The earlier they know, the easier it will be to implement it for the actual exams and the mocks, because if you don't do it in the mocks, then you won't be used to it in the actual exams.
Yeah, you need to get used to all of your access arrangements. So if you get someone who scribes for you, or if you use a computer in your exams, you've got to practice using those under those exam conditions. Okay, right, next one. There are huge numbers of options open to you. So don't think that the next step has to be to go to university. Maybe that's for you, but maybe an apprenticeship might be more appropriate. Maybe you should take a year out and let your head, I would advocate that, you sort of lose your academic, sort of concentration on exams thing, and get some perspective back into your life. Have a gap year before maybe you go off to university. But there are lots and lots of options open to you. You don't have to do everything the same way as everybody else. You're individual. Okay, so things other than A-levels can count towards your UCAS points. To help you get into university. So your EPQ can, for example, that's worth half an A-level. Music, so if you're good on an instrument or singing or something, drama qualifications can count. And those, I mean, there are lots and lots of them that you could use to help you get into your university of choice. You don't have to go to university right away. If you apply, even if you said you wanted to go, you can change your mind at the last minute. I mean, my niece, she actually was at her university for most of a month before she said, I can't do this, it's not me. And she stopped. She came home and she applied for a different university, a completely different, I mean, she was, she went from midwifery to archaeology and anthropology. I mean, what a change. But anyway, weirdly, she's a stage manager now. So, but yeah, you see, you don't have to do the normal thing. You can do your own thing. Everybody's an individual. Okay, even if you do get a place, you don't have to take your place up straight away. You can ask for it to be deferred. Not all universities will do that for all courses, so you need to check. But yeah, there's always options. There's options, options, options. So thinking about having a proper safety net, a proper lower grade, consider a gap year. There are sponsored apprenticeships. Some apprenticeships you can apply for through UCAS, but not all. And there are plenty of apprenticeships that don't go through UCAS. Even if you go through UCAS, the application deadline dates are not the same as the application deadline dates for applying for university courses. So be aware of that. If the worst comes to worst and you do struggle with your A-levels, foundation years is better than resitting. Nearly always, all the same problems that you had when you couldn't do your A-levels, they still exist, and resitting is unlikely to improve your grade. I wouldn't recommend resitting, hardly ever. Okay, so carefully consider what type of university you might want to go to. This is after you finish your A-level, and you can change your mind at any point. At any point. You can change your mind. Keep things in perspective. Okay, right, now I am going to come on to the tutoring offers. I'm aware that some of you have been here for a very, very long time. What I'd like to do is to tell you about two different offers.